So you have the notes in front of you. And so, so everyone should have these notes in front of them. And I'm going to assume as I write stuff that you have these notes in front of you. I'm going to rewrite most of it to be that, but I may not write out the section title or some of the English I might not write so much. Like this one I'll probably end up reproducing the whole thing and work through it with you. This one I probably won't. I'll probably just state what I'm going to say and then kind of work through the problems. Okay. All right. So let's get to it. So let's talk about Euler-Cauchy. This is going to be a little bit more freeform, so feel free to ask any questions at any time. Interject here. So Euler-Cauchy. So the Euler-Cauchy looks like this. And so if it doesn't look like this, it's not Euler-Cauchy. It's not. A to the okay, where A and B are just some A and B are just some constants, right? So A and B exist in the reals. And so here, this is Euler-Cauchy. And so what would we guess here? Well, we'd make the guess that y is equal to some power of x, right? Because if y is equal to some power of x, if I crunch that through, let's just crunch the y prime would be m x to the m minus 1 power, and then y double prime would be m minus 1 to the x to the m minus 2 power. And if I just plug that in, and the reason we guess that is because I would always have x to the same power, right? In particular, x to the m, right? Because if I plug that in, I'll have x to the m, m minus 1 and m. Because here, if I plug that in up here, x to the m minus 2 plus 2 gives me x to the m. Then I'll have minus a x times x to the n minus 1 will give me x to the m times m plus, and here if I plug in for y, I'll just get bx to the m equal to 0. So notice here I have x to the m and all this mess. So m, so I have m squared minus m plus am plus b. That's a plus, sorry. Is equal to 0. X to the m. Well, when x is 0, this is true, right? But I need this to be true everywhere, not just when x is equal to 0. Okay? And so this, obviously, is not with 0. So this needs to be 0. And so for this to be to 0, we'll produce the auxiliary equation. So here I'm just going to move stuff over. So here I'll have m squared from here, and then I'll have a minus 1. So it'll be plus a minus 1 times m plus b is equal to 0. Okay, and notice this is a minus 1. So when I write out the Euler-Cauchy, one of the most common things I see students do wrong, not because it's just they'll say, oh, this is a characteristic equation, we'll just write m squared plus am plus b. You need to take 1 off your a just because of how the math worked out. So make sure to do this. Okay. And so again, we're going to have 3 cases, right? We're going to have 3 cases here. This can give me real solutions. So I can have m1 not equal to m2, but they're both real. I can have m1 equal to m2. Notice this, because what are you going to do this? You're going to just throw it through the quadratic equation. So you're going to solve for m, right? So you can have it to be real, you can have them to be the same, or you can have them to be complex, where m is equal to some alpha plus beta I. Okay. And so let's just crunch through a couple of these real quick. And so here we're going to have y equals to, let me just make up let me just use the example I have here. So I have y squared equals y double prime plus 1.5 yx prime minus 0.5y. So if I was going to solve this, how would I do that? Well, I would just write this out. You don't need to solve this each time. You don't even need to show me solving it, right? Just m squared. Here, a is 1, or 1.5. So 1 minus 1.5 is 0.5. Okay, x. I guess the very first time I do it, I probably should show what I'm doing. M minus 0.5 is equal to 0. So you just write out this equation. They call this equation the auxiliary equation. Just the name is different than the characteristic equation. So this is the auxiliary equation. So here I get m squared. So this is my first one. M squared plus 0.5 m minus 0.5 equal to 0. Okay. And so let me I guess I don't have this in my notes, but step 1, write the auxiliary equation. Write the auxiliary equation. That's the first thing you need to do. Just write out step 2, right? Solve it. Solve for m. And so in this case, we solve for m, we're going to get the following. So here we'll get m1 is equal to 0.5, and m2 is equal to -1. Now, can I show you how to factor this and do it? Yeah, sure. Does it matter? No, everyone's going to put it in a calculator. Let's be honest, right? I could have literally like one of the most basic, things here. It could be like x plus 2x, or x squared plus 2x plus 1. And I can almost guarantee you guys are chunking through the calculator instead of just factoring x plus 1, x plus 1. I can almost guarantee it. I was that way in grad school. I do too, just to make sure. So here we're just crunching through the calculator. So solve for m via calculator. I don't care. I legit don't care. All right, so then we're going to write out a general solution. So the general solution in this case, right, is, so in this case, the general solution, so step 3, write the general solution. And so your general solution is going to matter based on what this gives you. So write the general solution. So since these are two different, we're going to have y is equal to, y is going to be equal to our first solution. I guess I never said what the solutions are. Well, the solution is, this is the solution, right? I told you what the solution is. And so if I have two different m's, that's two different solutions. So the general solution is C1 times the first solution, which would be xm1 plus C2 xm2. Well, in our case, if we're going to write out a general solution, this is just y equal to C1 x to the 0.5 plus C2 x to the -1. Now, if I was being, and I always just leave it as powers. Now, technically, can I write this as C1, the square root of x, plus C2 over x? Sure. Does it matter? No. So that's it. Here's the general solution, because I didn't give us a particular solution. I didn't give us anything to solve for. Now, if I had a particular solution, a step 4 would be solve for solve the initial value problem using initial conditions. So if I had two initial conditions, I just plug them in and solve for C1 and C2. Okay. Now, in this case, is it a little bit more complicated? Yes. Why is that? Because you're going to get, no, actually it's not, because you're going to plug in values for x, right? And so whatever x's it are, they'll just evaluate to a number. And so you're going to have a linear equation. So two equations with two unknowns for x, and powers of x. That's why I just leave it as this, for power rule when you take the derivative. It just makes life easy, right? Because power rule just. Okay, so that's all we're going to be doing here. All right, so let's just open up another page. I'm going to kind of bounce back between two pages in case you guys ask me to go to go back to the last page, but all right. New page. I want a new one. Boop. Give me a new one. Give me new stuff. Yep, great. All right. So I'm gonna make. Who doesn't do that? I'm waiting for the point because with the Apple's trying to make Apple Glass where you, and there's a couple companies working on it, and I think it will happen, right? Where you wear glasses where it has like the AR, right? Where you have like stuff here and stuff here. And so, and I can almost guarantee it can look at it'd be really easy to write in the algorithm. It'd just be so easy to write in the algorithm. You could look in a math equation and solve it for you, right? Automatically. I just see it happening, right? Or you can, when you look at something, it'll automatically translate it and put the translation in front of your eyes. I mean, it's going to happen, guys. Let's just face it. Your phone can do it. And once they learn how to do the glass a little bit better and integrate it. The only problem is they're highly hesitant to put cameras in it. And you know why? Does anyone know why they're hesitant to put cameras in the first set of glasses? Does anyone have this? You're a bunch of engineers. You should know.
Privacy concerns, probably.
Privacy concern is the absolute correct answer, and it's not the person's privacy concerns; it's
everyone else's.
Because if you're staring at someone who has an active camera and mic on you, you're going to be pretty careful what you say and do, right? But just to let you know, Big Brother's already watching. My mom had to get her hearing aids fixed, and so they could tell her how long she was in a car, how long she was out in public, how long she had them in, how long she was watching TV. The whole list. They could pump out the numbers when and where and how long.
I mean, we all carry like tracking devices with microphones on us willingly, so
right. People's like, well, they're gonna put a microchip in me. I'm like, the government doesn't need to. They legit don't. You purposely carry around this, which does all that for you.
done their job already. They don't need your help.
So, why is it all blue? Why is my new page blue? I don't even know how it got blue. Oh, someone's writing on my screen. Like, why is it blue? I'm losing my mind. Whoever wrote stuff on there, could you clear it out? Or I can do it. How do I do it? Annotation? Yes. Clear. Bam. Clear all drawings. Whoa. Haha, I got power. I was losing my mind. It's like, I don't even have that color up. If you guys all want to test my sanity, you'll find how fragile it is. Next thing I'm wearing like a banana hat. Why is it red? Oh, because it thinks I'm annotating. No annotate. Clear. Clear. Go away. Shoot. Bye-bye. No annotation. Oh, I'm going to lose my mind. Annotation. Clear all drawings. Get rid of annotation. Give me back Photoshop, and then I'll be clear. All right, so let's go back to it. So let's look at the double root case. So let's look at the double root case. So here you have m1 equals to m2. So in this case, you're going to have your first one equal to y equal to m1. And the second answer here, the second answer, in order to prove that this is the second answer, you do reduction of order on the the nonlinear system to a first order, and you get this to be the other solution. I'm not going to go through that. I'm just not. I'm never going to test you on it. We got better, more important things to teach you. All right, so let's just do this example. So here we're going to have x squared y minus 5y, or xy prime plus 9y equals 0. All right, so the first step, we'll do our step one. Our step one is write down the auxiliary equation, sorry. So this becomes minus 6. So minus 5 minus 1 is minus 6 plus 9 equal to 0. This factors into x minus 3, x minus 3 equal to 0. Or not x, m. sorry, m minus 3, m minus 3. So m here, m1 equals to m2, which is equal to 3. Is our next exam is the week after spring break? Yes. It's after chapter 2. That's all I remember. I'll show you the calendar after I finish the section because I kind of am curious now. So once we do this, what do we get? And so here we have our general solution. So our general solution, if these are the two different solutions, would be C1 x to the 3 plus C2 x to the 3 ln of x. And these are our general solution. And then from here, you can plug in and find particular solutions. Let me show you the complex one real quick, and we'll go from there. All right, so let's do case 3. Complex roots. All right, so here we have complex roots. Why is there an ln of x? Oh, this ln of x comes from, so if I have m1 equal to m2, this is my first linearly independent solution. The other solution, so in that case, it'd be x3 and x3. Well, these aren't linearly independent, right? They're the same solution, the exact same solution. So in order to produce another new and linearly independent solution, we do reduction of order to produce this. It's just how it comes about. If you want to look how it exactly comes about, the proof's in the book. All right, so let's talk about complex roots. So here if we have m equal to a plus I plus or minus ib, then we have y1 is equal to x of x plus bi, alpha bi. Then I can go ahead and hold on. If I lose my voice, we'll just end class sooner than later. Then we can go ahead and split that of, oops, there's no x here. There's no x here, that should be a plus. Alpha plus. So here, I'm going to raise it to that power. So I can have x raised to the alpha plus x raised to the beta I. All right, so I'm going to show you something kind of weird. I don't know if you've ever seen this trick before. So here, I'm going to exponentiate this and take the log of it at the same time. So here I'm going to e to the ln of x raised the bi power. Okay. Then I can pull this out front as a multiple. So this be ln of x bi, and then since this is multiplied, I can raise it to a power. And I guess I'm leaving off the x alpha real quick. There's an x alpha here. And so that's where I get that from. And then here you can move this around, and here I can get e to the I of b ln of x. Well, once I have this, you guys know we're going to use so here we'll leave the x alpha. We're going to convert that into cosine and sine. So here I have cosine b ln x plus I sine b ln x. And notice here, this is a solution. But if this is a solution, this needs to be a solution, and this needs to be a solution. So we're just going to say y is equal to x to the alpha times c1 cosine of beta ln of x plus c2 sine of beta ln. Okay. And so this is how we get the general solution for that. Because if this is a solution to my equation, the real part better equals 0 and the imaginary part better equals 0. So that means this is a linearly independent solution. This is a linearly independent solution. So we just grab those. Okay. They're equivalent to these solutions. These ends up being equivalent when we use both solutions. Just looks funny. So let me just show you a quick example. Go back to this page. Let's just do a quick example. So we have x squared, y double prime, (1604y) equals 0. Here, when I write out my equation, this will be minus 0.4. Remember to take the negative. M plus 16.04. This is equal to 0. All right, so that means m is equal to 0.2 plus or minus 4i. And so our general solution here would be x to the 0.2, x to the real part, c1 cosine of 4, that's what my beta is, ln of x, plus c2 sine of 4 ln x. And that's it. And so Euler-Cauchy is just, it's kind of a, in math, we think that'd be a little bit niche, like, oh, only in this form will solve it this way. And it's like, well, it ends up appearing more than you think. So that's the end of the first set of notes. Let me open that up real quick. Let me talk about that for 2 seconds and we'll get it going. This class. Where did the 0.4 come from? Oh, so the 0.4. So here I have 0.6 minus 1 equals 0 minus negative 0.4. Okay. Remember, you always take 1 away from the middle term. How did you get? Just throwing this through a calculator. Yeah, let's do that real quick. So if I have m squared minus 0.4m plus 16.4 or 0.04 0. Through a calculator. You can use quadratic equation. Now, do I even need to do this? Somehow I don't think so. Here, if I type in y squared, probably going to be sad if this works as well as I hope it does. Let's find out. Where'd it go? I know I saw it. Yeah, here's the solution.